Hello everyone, and welcome back to another video. Yeah, let's just get right into it. Actually, not really. I tried to look for some cube problems, but there weren't that many. I'll try to narrow it down a little bit and find like the easier ones so that I can make a video on that. But for now, we're gonna do the stack instead, which when you look at it, there's 176 questions, which is a lot. And the first one is very easy. So I'm just gonna do a quick stack and then call it a day. Once again, same thing. I'm gonna read the prompt, explain what it is, what they meant, write out the code, and then explain the line by line. And then afterward, I'll add in the time complexity and space complexity. After all of that, it should be good. And then I'm just gonna call it a night. And then make a new video right afterward. Okay, so 20 valid parentheses given a string as containing just the characters, the parenthesis, curly bracket, and bracket, determine if the input string is valid. An input string is valid if 1. Open brackets must be closed by the same type of brackets, 2. Open brackets must be closed in the correct order, or 3. Every closed bracket has a corresponding open bracket of the same type. As we can see, here's example 1, 2, 3, 4, 5. Very easy, very nice. Okay, so core idea is you read the string from left to right. If you see an opening bracket, you push it onto a stack. If you see a closing bracket, you want to do 3 things. If the stack is empty, that means it's invalid, return false. Otherwise, pop from the stack, and this is the most recent opening bracket. And then lastly, you want to check if this opening bracket and the closing bracket forms a valid pair. Now, once you finish every pair of every parenthesis must match each other. If they don't match, return false. Once you finish the whole thing, if the whole stack is empty, that means everything matched correctly. So you return true. However, if the stack is not empty, that means some opens never got closed. Return false. So this uses the LIFO behavior of a stack. So last in, first out. Let's start writing the code. First, I want to import a Java packet, which is stack. Now with this one, once I import it, I can basically just use pop, push, peek, is empty without having to write any extra, right? So, but before that, I want to first do s equals null or s.length, parenthesis, and then 2 is not equal to 0, and then return false. Now, for this part, very simple. If the length is odd, then if the length is odd, you can't really pair it, And if s is somehow null, then again, that's invalid. So, and again, think about it. It has to be an even number. So every parenthesis can pair with each other. If it's odd, it doesn't make any sense. That means one of them will not be in there. Or one of the opening bracket will be like left open, basically. And that would just basically return a false. So stack, character, stack, new, stack. Boom, 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 boom. Bam, boom, 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 boom. Done. And then we're going to write a for loop in I equals 0. And then I is s.length, boom, boom, boom. And then I plus plus. Now after that, we're going to have c dot this, boom, 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 boom. Now for this part, we're going to have an if. So inside if is basically this. Let's just copy this part and then paste, boom, boom, easy. Now this part is what we're looking at, all the opening brackets that we want to check, like if it's there. And if it is, we just need to push it, like how I explained earlier. We just push it. And then if not, then basically else, it's a closing bracket, right? So we want to check a couple of cases first. Number 1, we want to check if the stack is empty. Now, if it is, you want to return false. Other than that, you want to first create a top. And this top is going to have the stack.pop. Very nice. Let me remove the space real quick here. Boom, boom. Put some space. And then for here, we're going to put in a helper function. And before that, we want to first create the helper function. So private boolean is matching. So this is matching is going to help us check like whether or not if it's, matching, right? So for here, it's just going to return true or false, right? So what we're going to have is, I'm just going to write out first. We're going to have open. We're going to check the opening bracket, and close equals the closing parenthesis. We're going to have that, or, and then copy, boom, and finally boom. So as long as one of these matches, then it will return true, right? And the or is there to basically check it for us. So as long as one of them works, then it will return true. Now for this checking part is we're gonna put in if it's not matching, and then we put C and top inside, because the top is gonna be the open, the C is gonna be the close, and we just return false. Return false if it's not matching. And then I think that it should be it. At the very end, you want to return stack is empty, because if it is empty, it should return true. If it's not empty, it will return false. Now, that's basically the code done. So now I'll basically explain it. So here what we have is import stack. Like I said, this package is just making it easier so that I don't have to write out the whole push pop is empty, the whole line, So, and then again, it already has it just basically has the built-in LIFO structure. So providing the push pop peak and is empty. Now, what I have here is the early part, this part is basically checks if S equals to null, that means somehow S is null. That's not valid. Or if the number of characters is odd, we can't possibly have every bracket in a pair. So that's if either condition is true, we immediately return false. Afterward, we want to create a stack. This declares a stack of characters, and we basically store all the opening brackets into it. And so initially right now, it's empty. What we have here is the for loop. Now, it's just the standard for loop from index 0 to s.length. And what we do is we just, for the C is just gets the ith character of the string, right? And then C will be one of the opening, closing parenthesis, curly bracket, Now, what we have here is case number 1, which is the opening bracket. As long as we find, if C is one of the 3 opening brackets, we just push it. We push the stack. So put this opening bracket on top of the stack, and then so in a way it's basically saying we've opened something. We expect a matching closing bracket later in the correct order. Now the else part will be if it's not an opening bracket, it must be a closing bracket. So the else here must be a closing bracket. Now with this part, it also has its own cases where we want to first check if the stack is empty. Because if we see a closing bracket but the stack is empty, that means there was no opening bracket to match it. So if that's the case, you just want to return false, which is right here, return false. And then afterward, you want to pop the top, which is last opening bracket, right? So stack.pop removes and returns the top element from the stack. And this is the most recent opening bracket we saw. We store it in the top. This is the opening bracket that must match with the current closing bracket C. So right here. Now, this part is what I previously explained, which is from the helper function, right? What we do is, all we're doing is we're just checking if they form a valid pair. And just by looking at it, you can kind of see what I meant by that. It's just it will return false. If it return false, we return false from the is, this just kind of means that when, let's say for example, right here when I put in the top and C, right? Let's say top is equal to the opening parenthesis, but C is equal to the closing bracket. That's not a valid pair. So in that case, the bracket order is wrong, which means it's an invalid string. It's an invalid string. So when that happens, it's just going to return false. Pretty simple. Easy as that. So after the loop, stack must stay empty. So basically, after we finish scanning the entire list, if stack is empty, like when it comes out to be true, that means all opening brackets were matched with correct closing brackets. So that's valid. However, if it's false, that means there are still some opening brackets left that were never closed. And that's why this whole thing is just showing like whether or not it's true or false, right? So very simple. And then let me run the test case real quick. Hopefully there's no error. Okay, there is an error right here. Oh, forgot to close it. All right, there we go. Perfect. Now, while it's loading, which very fast. Okay, there we go. Test case 1, 2, 3, 4, 5. Very easy, very easy. They're all very true. You know, so in a sense, it's not like very difficult. You know, if you really think about it. And then before I submit it, I'm obviously gonna write out my time and space complexity. So time complexity and time and space actually are both going to be big O of n. So it's interesting because, not that interesting, but for time complexity, with the for loop over here, we basically loop the string once. And then inside of each operation, each operation inside the loop is big O of 1. It's just one operation. Because push, all you're doing is you're pushing a number and that's it. Same with pop. For stack is empty, we're just checking is it empty and then the match is just a few comparison. So total time should be big O of n, where n equals let me write out, where n equals s dot length, whatever the length is, put s. Now so let's say even if we return early, right? So like in some cases like mismatch or odd length, the worst case is still big O of n. So it's not going to change the time complexity. Now for the space, we use a stack that in worst case can store all characters when the string is all open brackets. So let's say with the worst case, right, what we're storing is all open brackets. So it looks like this. Then the stack size is going to be big O of n because we don't know how big it is. If it's going to like continue on forward, then it's going to be like n size basically. So space would be big O of n in the worst case. So let's submit it. Okay, there we go. Boom. It's not, up here, but like everyone average is about like there, and then I'm like here is about the same thing. So for time, it's already optimal. There's really nothing much you can do. So there you go. All right, that is about it for the video. Thanks for watching. I will try to find a new problem on Q or maybe another problem on stack before, moving on to a new topic. And I kind of just want to go a little bit faster now, try to post as much as I can. But thanks for watching.